What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're looking at our last lesson in Chapter 4, Similarity and Transformations. We basically want to be able to understand what would similarity look like in a transformation and then also prove that they are similar. So let's go ahead and begin by talking about our vocabulary terms. A similarity transformation or similarity transformation is when a dilation or a composition of rigid motions and dilation occurs. So that just means you have a dilation within a transformation, or you have rigid motions, which is reflection, rotation, or translation, followed by a dilation. And then similar figures are when two geometric figures show a similarity transformation on the map from one figure to the next. Let's go ahead and talk about what each one of those would look like. The first example we have in our notes is to graph it, translate, and then dilate a figure. So let's go ahead and graph the original figure with the following ordered pairs. So here's our first figure, ABC, at -4, 1, -2, 2, and -2, 1. Now we want to translate by going 5 to the right and 1 up. Remember, we can do that by choosing a point. So you can start with point A and go 5 to the right, 1, 2, 3, 4, 5, and up 1 would get it at 1, +2. Let's go ahead and do that same thing for points B and C. Now we have the following points labeled after the translation for A prime, B prime, and C prime. What might be helpful is to go ahead and label A prime, B prime, and C prime so that we can dilate it correctly. So let's go ahead and label those points for A prime. A prime is at 1, 2. B prime is at 3, 3. And C prime is at 3, 2. What I want to do now is dilate it by a scale factor of 2. So that means all I'm going to do is take all my points and multiply them each by 2 to figure out where my new points would be. So A double prime would be 2, 4. B double prime would be 6, 6. And C double prime would then be 6, 4. Let's go ahead and plot those new points on the coordinate plane. Here are my new points, A double prime, B double prime, and C double prime, and you should notice that the triangle has grown twice the size. Here's another figure, and it says describe a similarity transformation that maps trapezoid PQRS to trapezoid WXYZ. Go ahead and take time now to pause, determine what you think is happening first, and when you're done, click play to check your work. All right, the first thing I thought that happened is I thought that it reflected over the y-axis. This would be considered a rigid motion. And if it was reflected over the y-axis, that means S prime would be all the way over here. Q prime would be at +3. So -2, -1, 0, 1, 2, 3. And then P prime would be at +6. R prime is still going to stay there. So what I'm going to do is show you first that reflection here in purple. And I misstepped one of these, so let me go ahead and fix that as well. P again is at -6 and actually put it at -7. Here's P prime. Okay, now that I have those plotted correctly, R prime is still going to be on the y-axis. Now I need to notice, how did it change from one to the other? P prime is going to correspond with point W. So P prime right now is at 6, 3. And then W is at 1, 2, 1. So it was a reduction. So the second transformation that happened after the reflection, it was a dilation where K is equal to 1/3 because we're dividing by 3. So remember, you can also do that by finding the new shape, which would be 2, over the old shape, which would be 6. So 2/6 does reduce back to 1/3. That is going to conclude our examples for